The science behind baking bread. Understanding the heat equation. Have you ever wondered why the perfect loaf of bread has a golden crust and a soft, airy interior? The secret lies in the science of heat transfer. In this video, we will explore the heat equation and how it governs the baking process, ensuring that each loaf rises beautifully and cooks evenly. Understanding this phenomenon is crucial not just for bakers, but for anyone who enjoys the delightful aroma of freshly baked bread. So, what really happens to the dough when it hits the heat? Let's dive in and find out.
Heat enters from the oven and moves through the cake or dough from outside to inside. This process, described by the heat equation, a formula that shows how the temperature changes over the time. Heat moves from the hot surface into the center. This process is described by a math formula called the heat equation. The outside heats up faster while the center takes time. This is because heat diffuses slowly inwards. Moisture, density, and temperature effects, how heat spreads, and all represented in this formula. So, the next time you bake, remember it's not just cooking, this is a heat transfer driven by a beautiful math.
So, what is meant by PDE? PDE stands for partial differential equation that contain multiple variable, unknown function, and partial derivatives. So this is example of PDE, which is heat equation. How does PDE related in real life? It used for design cooling system in electronics, optimize industrial processes, and improve energy efficiency.
When bake a bread, you don't just throw dough in and hope for the best. The environment like oven temperature, airflow, and humidity plays a huge role in how the bread cooks. In baking bread, PDE commonly uses the heat equation, which models how temperature changes inside the dough over time. Let's see how the process happens. At the time 0, the dough is in the room temperature. And now, we heat it in the oven, and this is where the boundary condition come in. The heat starts from the surface and slowly move inward, causing the crust create at the outside while the inside staying soft longer.
It's a conclusion, right? Now, let's us conclude that heat equation models on temperature changes over time, which is du dt equivalent to a d square u over dx square. It's an example of partial differential equation. Help predict heat flow in real-world system, essential for solving real-life problems. That's all from me. Thank you.